Hey everyone, in this video, we're tackling another indeterminate form, but this is from section 7.8 involving the form infinity minus infinity, and we'll simplify the expression algebraically and use L'Hopital's rule to evaluate the limit. Now we are asked to find the limit as x approaches to infinity of x minus square root of x squared minus x. At first glance, if we try to apply x by infinity, both x and square root of x squared minus x goes to infinity, and so we're dealing with an indeterminate form of type infinity minus infinity, but we can't apply the L'Hopital's rule from it. Now, to handle this, we multiply the conjugate to simplify. The conjugate of x minus square root of x squared minus x is x plus square root of x squared plus x, and we multiply, and so we have here the limit as x approaches to infinity of x minus square root of x squared plus x multiply to its conjugate, which is x plus square root of x squared plus x over x plus square root of x squared plus x. And this gives us, if we multiply the numerator, we get the limit as x approaches to infinity of x squared minus square root of x squared plus x raised to the power of 2 over x plus square root of x squared plus x, and we cancel the square root and the power of 2, and so we have now the limit as x approaches to infinity of x squared minus x squared plus x over x plus square root of x squared plus x, and we distribute the negative sign to x squared and positive x. So we have here now the limit as x approaches to infinity of x squared minus x squared minus x over x plus square root of x squared plus x, and x squared minus x squared got cancelled, so we only have left negative x. So the limit as x approaches to infinity of negative x over x plus square root of x squared plus x. At this point, if we apply the limit as x approaches to infinity, we have infinity over infinity, which is also same as to an indeterminate form. And since the limit is an indeterminate form, we can now apply the L'Hopital's rule, wherein we derive the numerator and denominator. First, derive the numerator, which is negative x, and the derivative of negative x is negative 1. And as to the denominator, it's a bit complex, so we derive it step by step. And we have here x plus square root of x squared plus x. The derivative or the derivation of x is 1. And as to square root of x squared plus x, we treat this as a composite function, and let's break it down using the chain rule. Let function of x or f of x be the square root of x squared plus x, and the square root of x squared plus x can be written as x squared plus x raised to the power of 1/2. Then we apply the chain rule. Then we get 1/2 multiplied to x squared plus x multiplied by 2x plus 1, which is the derivative of x squared plus x. And so we have 1 over 2 multiplied to square root of x squared plus x multiplied to 2x plus 1, and 2x plus 1, we multiply this as a whole, and we get 2x plus 1 over 2 multiplied to square root of x squared plus x. And so we get the derivation from negative x over x plus square root of x squared plus x to negative 1 over 1 plus 2x plus 1 over 2 square root of x squared plus x. So, as you can see, we'll break this down step by step from 1 plus 2x plus 1 over 2 square root of x squared plus x. So this is from the denominator, and we're going to break this down since it is a complex fraction. So from 2x plus 1 over 2 multiplied by square root of x squared plus x, we can rewrite x as 1 plus 1 over x. So we have here 2x plus 1 over 2 square root of x squared multiplied to 1 plus 1 over x. And the square root of x squared is x, so we have 2x plus 1 over 2x square root of 1 plus 1 over x. And we got to solve the complex fraction from 2x plus 1 over 2 square root of x squared plus x. We have 2 plus 1 over x over 2 square root of 1 plus 1 over x. Now, applying the L'Hopital's rule, we already derived the numerator and denominator. So we have limit as x approaches to infinity of negative 1 over 1 plus 2 plus 1 over x over 2 square root of 1 plus 1 over x. Then we apply the limit as x approaches to infinity. We have negative 1 over 1 plus 2 plus 1 over infinity over 2 square root of 1 plus 1 over infinity. And 1 over infinity is 0, so, and 2 plus 0 is 2, and the square root of 1 is 1, and 2 multiplied by 1 is 2, so we have negative 1 over 1 plus 2 over 2, and 2 over 2 is 1, so we have 1 plus 1 is 2. We got an answer negative 1/2. Therefore, the limit exists, and the limit exists at negative 1/2. So by using the L'Hopital's rule, since applying the limit at first step, we get the indeterminate form infinity over infinity, which is also same to as 0 over 0. We apply the L'Hopital's rule, wherein it says that we derive the numerator and denominator. And so we get negative 1/2. Therefore, the limit exists.